All right, well, thank you, Drew. So I once saw a video on public speaking where the presenter said that you shouldn't open with something boring like "I'm Nick and this is infrastructure as code with Idem." Instead, he said that you should open with a shocking statistic. His example was, there are more people alive today than have ever died. He repeated it for emphasis. There are more people alive today than have ever died. So I thought about it for a little while and I Googled around for a shocking statistic that might be helpful for me. And so here's mine. 1/3 of adults still sleep with a comfort object, like a teddy bear. I think I may have missed the point of that video. So Drew gave me a good intro, but I'm Nick Hughes. I'm an automation consultant and co-founder and CEO of EITR Technologies. I'm old. I've got a lot of time in with the SALT open source project, which will be relevant in the context of this conversation as we start to dig in. I'm also the captain of the SALT Cloud Working Group. I have experience with other automation frameworks, and like all good automators, I am extremely lazy. So we'll be going over this list. I'm not going to read it out, but basically we'll be doing some things in regard to SALT, just sort of to put things in context. We'll talk a little bit about what Idem, the main topic of conversation, is built on, which is POP. And then we'll get into some demos later on. Okay, so we're going to start with a brief history to put things in context, like I said. So in the beginning, there was nothing. And then there was Thomas Hatch, smart guy. And Tom gave us SALT, an event-based automation framework. And then there was the cloud. And Tom said, we can do that too. So basically, SALT Cloud was implemented very early on in public cloud. So a lot of the public cloud providers were really just providing virtual machines, right? That's all you could do. And so as a result, because SALT Cloud was written during that time, it really can only do that to this day. It's really only for computes, for spinning up instances of virtual machines inside of a given public or private cloud environment. Has an entirely different workflow than the rest of SALT. It's built on this sort of merged YAML for providers being the overarching information about a specific cloud provider that you want to work with. Profiles being rough estimates of what instances might look like. You could think of them as like types or flavors. And then maps build on top of that in order to spin up large numbers of virtual machines inside of that given provider. It doesn't have the same Jinja support as the rest of SALT. You can't use execution modules and some other things inside of the Jinja that you would write inside of, say, a map file. So it's completely different. As a result, it's usually implemented in orchestration states where you have a wrapper state that might spin up infrastructure using the normal state modules, and then afterwards come through and spin up the cloud instances using SALT Cloud. As a result of this weird workflow, some state modules do exist for compute inside of the normal code base. I think AWS has a state for instances, but it's not pervasive. Okay, so let's take a break from the past. Hopefully that will help to put things in perspective, give a little context as we move on, but really what we're talking about here is the future. So let's talk about POP. This is the paradigm on which Idem is built. Basically, Tom identified some problems in his time working with the SALT open source project and from observing other projects as well. They become large projects over time with complex code and slow releases. And Tom references the Mythical Man Month in his book that's on Read the Docs on this subject, which I've linked farther in the presentation. Mythical Man Month is a book written by Fred Brooks in like 1975. And inside of that book, he basically says that hiring more engineers doesn't yield proportional returns, right? So more code takes more people, but less innovation occurs. So this is really just for reference again, talking about large projects, right? And sort of the reason why POP exists is SALT is a very, very large project. And one of the things that people love about it is its pluggability. It's very easy to write new functionality into the code base. Unfortunately, that code lives in the same repository, right? All of these plugins, and this is just the sample. This is nowhere near the number of plugins that are actually available inside of SALT. All of these plugins live inside of the main code base. So it just grows and grows and grows. And that one open source project has to maintain and test all of this code. So what is POP exactly? I'm not going to do this nearly as much justice as Thomas Hatch would. He does entire like hour-and-a-half presentations on what POP is. But the quick and dirty of it is that POP is a framework for writing pluggable code. It's written in Python. And it follows the Unix philosophy. So the Unix philosophy says you do one thing, you do it well, you write programs that work together, and you write programs that talk the same language, right? So in the context of actual Unix applications, right, they might do a small thing, and then you would use a pipe operator in order to pipe a text stream into the next application. So that's the common language there, is a text stream. So basically, Tom had this idea that if we wrote smaller atomic units of code and then had them linked together through some sort of common framework where they could all talk to each other, it would be in the same vein as the Unix philosophy. And so everything becomes a plugin. Whatever small things you can think that could be done with any application, that becomes an app in and of itself, a plugin that could then be used either standalone by itself or by any other application that's written in POP. Additionally, you can extend POP applications, and then you merge all of them together. So different standalone applications can be merged together and take advantage of functionality that's presented. Plugins can be merged to extend the functionality of a given application. And it's really, really easy to do. And so as a result of this framework, we get smaller projects, faster releases, and more innovation. So Tom and some other folks that were early adopters set out to write the next generation of pluggable components. And so a lot of this functionality spawns out of what SALT has been in the past, but some of it's brand new and some of it's taken to the next level. It's evolved. So at the top here, we have POP itself. All of this is inside of GitLab and SaltStack.org POP project. You have POP corn, which is kind of like Salt's grains system, written as its own application, so you can get information about your systems, right? So you know, your BIOS model, how much memory is on the system, CPU, all of that information is available inside of Corn. Idem, which we're going to be speaking about today, which is really if you took Salt's execution and state system and brought it out of Salt and made it its own little thing, that's really what Idem is. Heist is an evolution of Salt SSH in a way. It's really way cooler than that. It uses SSH as a transport, set up tunnels to a number of systems. And then what it does is deploy a dissolvable agent to those systems that can then do things. So in the context of Salt deployments, you could have Heist reach out to them over SSH, stand up dissolvable agents, all of them call back to the master. You run automation to do system configuration or whatever you need done. And then once that's completed, you tell Heist to go ahead and tear down those connections, and the agents just go away. They aren't long-running agents. It's a really, really neat project. Account and Rend are ultimately helper applications that Idem leverages, but you know, could be used inside of other projects. Account for encrypted account credentials for things. In the context of Idem, we're going to be seeing it in the context of cloud tonight. And Rend is a template rendering system. And then Takara is kind of a neat project, but it's really early on in development. You can think of it right now as almost like a standalone local and somewhat easier to manage in the sense that you don't have Shamir secrets, HashiCorp Vault. So same context in the sense that you have encrypted secrets that sort of have a path to them in order to get and set those different secrets. So here we see those same projects sort of broken down in a hierarchy. All of these applications in the context of POP really become libraries where applications can be merged together and leverage functionality in each other. So there's a concept of both horizontal app merging and vertical app merging. And I'm going to read my notes here because I always get things confused, and I put them in the opposite order on this slide. So I don't want to get too confused. But horizontal app merging is where you access other apps through the hub. So for instance, vertically, the teal color on my slide, that would be horizontal app merging if all of those apps were merged together into one cohesive unit. So Idem, for instance, would take advantage of account and Rend as subsystems when we're doing things inside of the cloud. And then you have vertical app merging, shown horizontally on my slide, which is basically extending more functionality into these applications by merging in plugins, right? So a great example of that is Idem, and the Idem Azure RM project, which we're going to learn about tonight, gets merged into Idem in order to add Azure functionality to Idem's stateful system. So we've talked a little bit about Idem already, so it's probably good that we define it now. Idem, short for idempotent, is really a configuration management system, right? It leverages remote execution and stateful enforcement of configurations to manage systems that are in scope. So right now, you know, we're going to be talking mostly about cloud because that's really the first thing that's ready. You know, this is all in active development. This is really early, but there's some exciting things happening here, and we have some good and stable work being done against the Azure cloud. Uh, so Idem has execution modules and state modules. Execution modules do things atomically, and state modules do things, but only if they need to be done in a really simple sense. All of this is perfect for cloud because with POP applications, you can keep plugins in separate repositories. So the Azure specific code for Idem is in a separate repository from the rest of the Idem code base. Developers can work on Idem and extend that functionality at a base level. And developers can work on the Azure functionality inside of the plugin separately, and they don't have to wait for each other. Especially with cloud, we want to move really fast, right? The new services and new functionalities being released all the time. And so if we had to wait for a large release of a larger product, it's just not feasible. And really that's what we're seeing right now with Salt, right? There's a lot of great functionality inside of Salt proper, but we have to wait for the releases of Salt in order to integrate any new cloud functionality in there, and it's just moving too fast. So the next two slides show things in the context of Salt. Idem does not have this functionality yet, at least not to my knowledge. Again, it's being actively developed. But really to understand the concepts of execution modules and state modules, so it makes sense as we're moving along. So this module shown changes ownership on a file, right? Just like on the Linux system. You could run this 10 times and it's actually going to execute each time against that file. So even though the ownership is already set after the first time, it will continue to run each time and change ownership because it doesn't check first. Conversely, state modules will check first, right? So we see the return from this state module run inside of Salt, where in the comment line, it says that no changes are made. That's because it's reaching out, seeing if the file is there, it's checking the ownership on it, making sure everything is right, and then it's returning back that status so that it doesn't actually run the execution module against that file. So now we're at Idem Cloud. So as opposed to Salt Cloud, Idem Cloud is for all cloud services and APIs. We're still building out functionality right now, but the intent is to capture anything that has an API for a given endpoint, right? So inside of the Azure repository, for every service that Microsoft exposes as an API, we should be able to do stateful enforcement or execution of some sort against that API, and it will live inside this repository. So that's pretty exciting. Also, instead of having a separate workflow, like we do for Salt Cloud, it's basically the same workflow that you'll see as more modules roll out for Idem, right? It's all going to be one application that does things by virtue of separate plugins being merged in. So before we get into the demos, I know I went over a lot of things in fairly quick succession. If there's any questions, I'd certainly be happy to answer those right now. You can ask in the chat, and Drew will parrot them out, or feel free to unmute yourself this time and ask away.
I have a question.
Yes.
My name is Justin. I worked at SaltStack for a while. So I heard about this technology recently, and thanks for giving the presentation. So the first thing I think of when you start talking about a plugin architecture, I mean, Tom loves plugins, is so you're talking about horizontal and vertical integration, but when you start getting any kind of complexity, like in the number of modules you're integrating or the complexity of their tasks, how can you foresee what those horizontal and vertical contracts are going to look like a priori with the POP architecture versus, you know, some DevOps dude or some production engineer down a couple years later is working with this system with dozens or even hundreds of modules. How does this architecture solve the inherent complexity of what that guy's doing? Do you just say, well, you're
Yeah,
probably approaching the problem in too complex of a manner to start with, so maybe you should start rethinking what you're doing in the first place, or something like that?
yeah. So, like I said, Tom goes into much more detail, and I think some of his talks might be recorded. I'll see if I can dig one up and maybe link to it after this. But POP has a concept of contracts. So any application can specify a certain interface, right? So it can say, hey, this is how I expect things to look. So in the context of cloud, right, you know, if we had a wrapper application that was just cloud specific, um, it could impose contracts on any of the plugins that say, hey, you know, your modules must have these parameters, must behave in this way, must return this type when it's spewing information out. So there are ways to enforce structure as there is sprawl, because I mean, that's a great point. You know, you have things living in different repositories managed by different people, and things can look very different. But the good thing is that, you know, if you cared about a certain thing and wanted to do it a certain way, you could certainly do that in your own repository and merge it in with any, you know, quote unquote, uh, official item plugin, and it would work just as fine, right? And the way that that is presented, at least right now, is through pip, right? So like all you would have to do is say you wrote a special plugin for Idem, you install Idem, and you pip install your special plugin, and it's just there. It can be used. Does that kind of answer the question?
Yeah, so you're just saying there's a pretty well thought out contract format or contract design to try to get people to think in generic terms, I guess,
Yep.
in the context of
Yeah,
learning.
definitely. And you know, I would definitely look up more information on that, because that's something that you know, you could probably talk on at great length. So check out the pop book that'll be linked, and I'll see if I can dig up a link to one of Tom's talks, and you know, Drew can send that out afterwards.
Okay, thank you.
And yeah, and I'll definitely get those links out to everyone after the meeting here. Nick, we've got a question in chat. Is POP used in any projects outside of SoftStack?
So yes, I probably should have looked up the exact name of it, but there's like a tools application inside of, I think it's like the Funbuntu distribution. The maintainer of that code base learned about POP and is starting to write like this tool set in Python using POP, because he can write little atomic plugins for the tool set. And you know, evidently that's taking off. I've heard about some proprietary projects that are leveraging POP in various ways, just because of the pluggability of it. So you think of it in the context of like, hey, you know, I have this application and I could have n number of backends for my database. So maybe I start writing out specific plugins for each database, and then I can just merge them in as I need them, right? So, you know, I could act against Postgres or MySQL or, you know, anything as a backend, just by pip installing a different backend.
Cool, thanks.
All right, well, let's go ahead and get started with the demos. Hopefully this will be the most informative and sort of bring things together a little bit better if it's not quite sticking. So let's see here. First, what we're going to do is we will go over a basic virtual machine implementation, kind of the bare minimum inside of Azure. Then what we're going to do is we'll jump up to a little bit of a more complex architecture. It's by no means anything crazy, but we'll get to see a little bit more object types inside of Azure and interfacing with those. And then finally, what we'll do is show something that probably shouldn't ever be done, but really just for the purposes of showing the pluggability of POP applications and how you can leverage code that's written for one express purpose in other ways. Okay. So, really quickly here. Drew, is that a good size? Do I need to make that any bigger?
It's okay for me, but I've got a big monitor. I'd recommend like one tick. Yeah, just one zoom. I think that'd be okay.
All right.
Is that okay for everyone else?
Yep. So, this guy here, this repository is up in GitHub. That link will also be sent out so that you'll have access to all of the things that we're talking about right now, for better or worse. So let me just show that real quick. So this is the README for that repository. You can see at the bottom, there's a bunch of references that you can link to, POP projects, kind of the architectures that we go over, and even how to get started. So we'll go through this top part really quickly, just so you know what to expect, and then we'll move on from there. So, like all good developers for Python, we're going to run everything in a virtual environment. And I'm on Ubuntu, so I don't get wheel for free. And then really all I have to do at this point is install just the Azure module. It's currently at version 2.2.
Hey, Nick.
Yep.
Interrupt. If we can, if I can beg you to make that just a little bigger. We've got a few mentions asking us to make the text tiny bigger.
Sure. How's that?
Let's see if we're going kind of async over chat. Let's just assume that's good, and I'll interrupt you again if it needs to.
All right. If I go any bigger, I might just have one character on there.
Right.
So installing Idem Azure RM will install Idem, POP, all the prerequisites. Additionally, you'll install the Azure Python SDK components and trying to pin as much as I can so that it's repeatable and expected output. There might be some functionality in this current version that doesn't necessarily match what you can do in Azure because I need to run through all of the requirements again and make sure that things don't break once I bump them up. But that should be coming soon. So now we have Idem Azure RM installed, which means we have the Idem application. And so we can look at the help here. We can pass positional arguments, either exec or state, and either call execution modules directly or pass in a state file and enforce a given state. So while we look at some of these files and their structure, what I'm going to do is kick off the actual runs in the background. Because they take a little bit. Oh, should probably be inside of my virtual environment that I just created. My fingers don't really want to work today, so I apologize for the slowness of my typing. All right, so now we actually have it. So let's go back to these files. So for the Tricycle, that's going to be our simplest architecture that we're looking at tonight. Let me jump over here real quick. So the Tricycle architecture really is just a resource group, which you need for pretty much all of the Azure resources, right? Now, there's some exceptions, but not many. It's going to stand up a virtual network and a subnet. It's going to spin up a public IP object, a network interface, and a VM with an operating system disk, and tie all those things together. And then it should be accessible over the internet because we aren't doing anything fancy like locking it down. So I'm sure you know, some of the people will immediately start trying to hack into it as soon as I show the IP on the screen. I know of at least one that would have fun with that.
Idle hands, Nick. Idle hands.
So this is the Tricycle architecture that I just showed, really. We're spinning up that resource group. So we have an arbitrary name of the state at the top, just like in Salt. We have our state module that we're calling. And the one notable thing here versus Salt is that we can have nested modules. So in Salt, really, you end up with one dot in your modules, right? You have the file that is your state plugin, and then you have the function inside of that. Inside of Idem, you could have an entire directory structure, and for Azure, that's what we have. So everything is nested inside of the Azure RM namespace. Everything is a folder underneath of that. So we have a resource folder, and then we have a group file, which has a present function inside of it. And that's how we're calling our state module. We're passing it the name of the resource group that we want to create and the location that we want to create it in. Then we are doing the same thing for a virtual network. So virtual networks have sub-objects as subnets, and you can actually define that subnet as we have here inside of the YAML, or you could create a separate subnet object and then just call out which subnet object needs to be referenced inside of the virtual network. Now that becomes a little bit sticky, right? Because you have to create the virtual network first, and then you have to reference it in order to connect it to. So a lot of times it's better to just do it this way. But there is a way that you can chain those together. Additionally, this is how things are right now, right? The goal here is to make things as dead simple as we can. So if any of the syntax or ways to use this become problematic, we certainly want to try and accommodate that and you know, try and be as simple as we can. And finally, the third little YAML snippet that we have here is creating our virtual machine. So here we're calling a virtual machine present. state. It is inside of our compute folder. And we're creating a virtual machine named VM Idem 001. We are telling it that we want to create it inside of the Tricycle resource group that we've already created. We're going to give it a size of standard B2S. The image is an amalgamation pipe delimited of like the what do they call it? It's not manufacturer, but like the creator of the image, you know, what type it is, what version it is, and all of that. This is actually the same syntax that's currently used inside of Salt Cloud. So for anybody that's transitioning, this should look fairly similar. Referencing the virtual network and subnet that we are looking to go inside of. And you'll notice that we didn't say anything about our network interface. That is actually because by default in Salt Cloud, it will create a network interface for you unless you tell it not to for some reason. So we follow that same workflow, and it's going to create a network interface for us and attach it to the subnet that we've defined. Additionally, instead of defining a public IP, we've created a custom parameter to allocate a public IP. So because that's true, it's just going to do all the work for us. So, you know, we're trying to be extremely lazy, like all good automators are here. And, you know, we have two objects here that we just didn't have to create. And then we're passing a public key so I can SSH in. All right, so looks like we had a problem over on the other side here, but at least we had one that worked. I did do an update yesterday, which was probably not a good idea, but I wanted to get some stuff out the door before this. So here is the output. These are a couple of info messages that are usually suppressed inside of Salt at info because Salt defaults to warn. I just did a pull request recently to change that in POP, so these info messages should go away. It's really just trying to see if something's there, and if it's not, it's going to create it. This error message is a known bug that doesn't really affect anything. You can see it's trying to find something weird in public IP addresses, but haven't tracked down where that's coming from yet. So you can see that we have created a resource group. It's been created. Here's all of the information about that resource group. Gives us the full ID path back. We have our virtual network information that was returned. Notice that some of these things weren't things that we specified inside of our virtual network specification in our YAML, right? You know, these are things that came back as a result of creating it in Azure, like defaults. And then our virtual machine. So all of this information about the virtual machine, here's our image reference, here's a publisher, that's what it's called, the offer, the SKU, and the version. Creates an operating system disk for that. We have an OS profile. Here's injecting my key, attaching network interface. So this is pretty big, right? Because virtual machines bring together a lot of different objects. So you're referencing the subnet, which is a separate object. You're referencing the network interface, the network interface configuration, which is a sub-object. Just a lot of references to other objects that you could follow if you really wanted to.
Hey,
Yep.
Nick, quick question from the chat. Can the public IP be further configured beyond the value of true?
Yes. So if you want to do anything other than have the virtual machine present module create it for you, what you probably want to do is create your own public IP, because then you could pass in whatever parameters you want to it. And then you would just reference like, hey, I want to attach this public IP inside of the YAML as opposed to just create one for me. So about that public IP, what we're going to do is run an execution module to pull that back, make this a little bit bigger. So you can see what we have here. It's wrapping, but we're going to item exec. Here's the execution module that we're going to run. It's Azure RM network. So those are two folders. This is our actual module, and that's our function. And then this is the name of the public IP, the resource group that lives in, and we're going to output in nested format, which is shown above. So we have our public IP address that we got. You can see that we have our IP address here. If you created a public IP address object separately, you could pass in a lot of these values, not all of them. Right? Some of them aren't modifiable, right? Like you couldn't change the type of a public IP address to something else. It just tells you what it is. It's a read-only property. So this should work and allow us to SSH to that IP. So you can see that by default, it's going to create an item user. You can override that as well. You can name your user whatever you want. But it's going to default to item because you could spin up any number of different operating system types, right? So you would have to know, oh, Ubuntu, CentOS, the Windows administrator account, whatever. This way, at least you have a standard thing. If you don't change it yourself, it's always going to be item if it's spun up with item. And look at that, we're in. We did a thing. All right, so really quickly, I'm going to deactivate this. I'm gonna activate another virtual environment that I have that hopefully doesn't have problems. Otherwise, I'm going to be yelling at the demo guys. And I'm going to run that guy while we were talking about the YAML over here. So this is the bicycle. This is a little bit crazier. So this is our bicycle architecture. I'm going to take a drink. I'm not used to talking so much with all this social distancing. So the bicycle architecture, again, we have everything inside of a resource group. We have our public IP, but this time behind it, we have a load balancer. So this should be a pretty standard Azure workflow, right? Creating a load balancer and allowing traffic in from the outside. That load balancer is attached to two VMs in the availability set. There is a network security group that is protecting traffic at the subnet level. So pretty much anything that's attached to it is going to be restricted to certain ports that we've defined. And what this is going to do is allow us to deploy 2 web servers and have a public IP address that we can hit and test out and see if it worked. So see right away in the Tricycle YAML file, we had 0 Jinja. Here, I went probably a little bit overboard with the Jinja, but I wanted to show that you could do it. And feel free to dig through a lot of this at your leisure and reach out to me if you have any questions. I'm not going to explain all of the things, but one thing to note here is that I did a little bit of magic to pull out the subscription ID so that I could run this against multiple accounts without hard coding a subscription ID in here. And then I was going to assign the subscription ID inside of the resource identifier. This is interesting because Jinja has access to the hub where all of the POP things live. So in this case, account, which has our account credentials in it, which includes our subscription ID, I can reference that information with a stanza like this on the hub, which is really neat. Basically hitting a separate application from inside of Jinja. We are specifying a bunch of tags and formatting some strings, and then we're down to our YAML. So all of these objects we're passing tags dictionary to, so we could specify multiple objects and they all have consistent tags, identifying who owns it, the organization that owns it, and things like that.
Hey, Nick.
Yep.
Pardon the interruption. Question out of chat. Talking, so we got your repo to go for as an example. Is there a collection of simple Idem examples somewhere that an interested
No,
party
not
could go
yet.
and research?
So you guys are getting a sneak peek, right? After the demos, I'm gonna get to a slide that basically talks about where we are, where we're going, and we're pretty early on in this journey. So a lot of the early, this is how you do things, is going to be coming from me, because Azure is probably the farthest along of anything. I initially ported over the functionality as a proof of concept at Microsoft Ignite last fall. So that was November. And talked a little bit about it at SaltConf, but not very much. And then we've been working on it since, right? Production on other Idem plugins didn't really start up until earlier this year. Corn is a fair amount along, but that has a very specific purpose, right? Pulling information out of a host. As far as like doing stuff with Idem, actually statefully enforcing things, most of it's going to be this. So, my repository has some things in there. All of the modules inside of Azure RM are documented with samples. So the documentation is pretty early on, but it's because it doesn't have any tutorials or any of that like nice stuff. Because we're pretty early on. It's a new project. But all the modules are documented, right? We're pulling the doc strings out. We're creating documentation on read the docs, so you can go ahead and look at samples and things like that. Like, hey, how do I spin up a virtual network gateway, right? Like get VPN into my virtual network. You can go and look at that sample, and it should walk you through most of how to get there. But there should be a lot more to come, both out of Azure proper and new plugins that are coming down the pipe.
Cool, thanks.
All right, so we've got a network security group here, right? Security rules are sub-objects. You can either specify them as separate YAML snippets or as sub-objects as we have here inside of a network security group. I find nesting related things to be better for my workflow, but you could do it however you'd like. So we're allowing all outbound traffic from the virtual network to the internet. We're allowing inbound traffic. I called it encrypted inbound because I copied and pasted it from an example I have. But you can see port 80's in there, right? That's the port that we're going to be hitting for this, this web server because I'm lazy. Again, I'm passing tags. We're creating a virtual network like we did before. We're attaching the network security group to our subnet here. We are creating a separate public IP object. So you can see that we're creating an IPv4 public IP. It's static, it's a basic SKU, and we're passing this domain name label of Devops Columbia so that we can reference it by name and not have to dump our public IP address in there to test our load balancer. We have our availability set, which is going to group our two virtual machines. We have our parameters that are appropriate for that. Load balancers are super complex objects. When I was writing this code, I wanted to gouge my eyes out. They're super not fun. I need to document this way better, but basically load balancers have a ton of sub-objects. So front-end IP configurations is actually an object, back-end address pools object, probe object, load balancing rules, list of objects. Yeah, really each one has to be documented against the SDK. It says, hey, here's all the different parameters that you can pass, but I tried to give an example here that was a lot of them. And you can see that we're calling out port 80 for our load balancing rules. We're using our front-end IP configuration, which points at the public IP. We're using our back-end address pool, which is going to be referenced by the virtual machines. And then we have a probe that checks to see if those virtual machines are up. So, if one were to go down, the load balancer would say, you're dead, I'm not going to deal with you. And then this whole section down below is inside of a for loop for Jinja. So, again, we would probably do something fancy like passing in a count or something like that of how many virtual machines we actually wanted behind this load balancer. But for the purposes of the demo, we have 1 and 2. So it's just iterating over top of the numbers. And then we're substituting that special I variable inside of all of the things that matter here so that they are distinct objects inside of Azure. So we're creating a separate network interface for both VM1 and VM2. We're attaching it to the virtual network, giving it an IP configuration that references the load balancer backend pool, and then having a virtual machine that references the network interface that we just created. And we're also passing in some user data. So you can see this is how I'm getting the web server on my CentOS boxes here. I'm just installing it. I'm not doing anything fancy because this is a pretty quick demo. And that should give us the desired output. So hopefully, oh, it broke. I don't know what's actually going on here. I'll have to look into that. But what it should do is pump out the architecture that I showed here. And then what I was going to do next was put that web server address into my browser and show you the default Apache web server page showing, hey, we did a thing. Unfortunately, I probably shouldn't have updated last night and ruined this whole thing. I apologize for that. And now that I'm sort of out of cadence here, let's jump to the unicycle real quick, and hopefully this doesn't bomb. So, crazy unicycle guy. Pretty early on in rolling out POP to the public, Tom wrote a quick and dirty application they called Poppy that all it does is expose an arbitrary API, right? So it's basically AIO HTTP that stands up a listener and listens for arbitrary function calls and does like some math stuff. And that's what Tom demoed in a lot of his early POP talks, at least. So what I did was I took Poppy, which is a web server that runs arbitrary functions, and I made it run an Azure resource group listing. So this is interesting because my app has access to Azure. It's been given credentials to be able to do things. But I could expose the ability to list resource groups or other functions to people over a local API that will only do things that I allow them to. Now, this isn't a great use case, right? Like, I can't really think of many reasons to do this in particular. I just wanted to show that I took a POP application, I extended it with some functionality by just pointing it at the Azure RM stuff that we've written. So, you know, there's nothing fancy going on here, right? Like, you can look at the code inside of my repository and see what's going on, but it's not a whole lot. Oh, not poop, Poppy. So let's run this app. And that's because I am in this new here. Let's see here. I want my, should just use this one for the entire thing. All right. Okay, so stood up a web server that we're listening on. And let's copy and paste this. So we're just going to use curl to hit our local API. I'm passing in a module that I want to run. So inside of Poppy, I extended it by passing in Azure RM RG list, and that calls resource group list as an execution module off of the hub. I'm not passing in any keyword arguments, and hopefully this returns JSON. Hey, it did. All right. So you can see that I have a resource group listing here. Right? Here's my super awesome group, my network watcher resource group. Let's default there. Looks like RG Bicycle was created. It's just some sort of sub-object that didn't stand up all the way, bombed out. And there's RG Tricycles. So there's our listing of resource groups here. And if we pop over to this, we went from having 2 resource groups to 4. So this is all the stuff that we stood up the first time we were in. Here's the bicycle. Looks like VM number 2 didn't want to stand up for some reason. I wonder if I could hit it with just one VM there. I wonder if that's stood up all the way. Let's see. Hey, all right. Well, at least we could show that it did half of a thing. We stood up VM1, VM2, decided it didn't want to play along. But we have our availability set, load balancer, NSG that we created, public IP, VM number 1 with its operating system disk and network interface, created the network interface for VM2, but didn't want to stand up VM2 for some reason, so I'll check that later. And our virtual network. So, hopefully that was a decent demo. I apologize again that it didn't quite work as expected for the second go round, but at least we got some output out of it. And where are we going from here? So Idem as an application, right now we're focusing on rolling out cloud first, because cloud is a really great fit for Idem, as I said. You know, first of all, Salt Cloud itself, I think has some traction, but not a huge user base. So, you know, if over time we move functionality over to Idem, I think that it wouldn't disrupt a ton of people. You know, the pluggability of it, keeping different clouds and different repositories will allow them to move very fast. Right now, we have the Azure repo that I'll link to that's in a fairly good state with the exception of the errors that we threw tonight, which should be fixed probably later tonight because I'll force myself to stay up and fix them. But we also have some more clouds that are in various states of completion right now in libvirt, Vagrant, VirtualBox, and Vultr. So the first three are like more local-ish, right? Cloud implementations, and that's on purpose because they're a little bit easier to write. You don't need a cloud account in order to do those, but make some good progress on those. And I think that some of those should be fairly functional, if not entirely. Vultr is another small public cloud that's out there. And that should be at least start to be usable. So, give it a shot if you're a Vultr person. But, I'm sure what everybody's asking right now is, what about the big guys, right? What about AWS and Google and Oracle? Those are coming. Right now, we're looking at AWS as our next one because of, market share being what it is. So hopefully we can make some good progress on that soon. We're also looking at, sort of like your mid-tier and your on-prem private cloud players like Linode, DigitalOcean for the former, and OpenStack and VMware and the like for the latter. And then, Idem is going to have configuration management that's akin to Salt over time. Right? It's a matter of time and people putting effort into it. So, if you want to pitch in and contribute to clouds or stubbing out some of the functionality that's in Salt inside of Idem, it's open source. Come on over. We'd love to have you. But the last thing I wanted to mention is we want to make this super easy, as I mentioned. Idem is all about being super user-friendly. So if there's any way that we can further abstract things and make things simple and allow you to dig down into objects, but then also be able to step back and maybe not have to care about the details, that's really what the goal is here. So, we might end up having some functionality like I showed with the virtual machine taking care of some of the sub-objects for you, scenarios like that, but also maybe like wrapper states that do things that are common workflows. So, always looking for input and help in that regard also. So these are the references that are in my GitHub repository. That is the last item on this list. Probably should have been the first, but you can get all these links from that link. The first two links are recent blogs that I wrote about how to do things with Idem in Azure. A lot of that you've seen this evening, but it has more words written down on a paper. So if you want to read that and learn from that, certainly a great place to do it. The pop book that I talked about that Thomas Hatch wrote, that has a lot of the high level reasons for doing things in pop and a lot of the terminology and sort of how things fit together and his vision. It's a great read, so definitely hit that. Docs for pop and Idem. The GitLab repository there is a project in which a ton of the SaltStack official pop modules are showing up. So if you hit that, you'll see a bunch of repositories in there that do things. Feel free to play with those. Underneath of that is the repository for Idem Azure RM. So right now we aren't in GitLab. I thought maybe we could move over there at some point for consistency's sake, but right now, I don't know, I like GitHub better, so that's where it is. And then we have the Idem Azure RM, read the docs. Again, that's where all of your module references are, and be on the lookout for additional documentation like tutorials and quick starts and things like that as we start to build out that documentation. So thank you very much. I appreciate being asked to speak tonight. And if you have any questions for me, we can certainly open up the floor again. I'm here for you. And if you start looking into it later on and want to ask me anything else, you can hit me at all of these places. So, you know, throw me an email or hit me up on LinkedIn, my personal and company GitHub pages. And like I said, I might move the project over to GitLab at some point in the future, but still not sure about that. So thank you very much.